All right, got a decent amount of people in here. Welcome everyone to Tableau User Group post Tableau conference. This is our first one since Tableau conference, right, Sean? For those of you that tuned in, hope it was good. Sean and I were at conference. It was great. Great to see everyone. Good experience. See everything live. I think the online, the virtual conference, Liam and Leah, was not like parity with what we saw in person, right? So like what was available online was like recorded sessions versus what like me and Sean got to go see were live sessions. Is that right?
Yeah.
Okay. Yeah. So again, I'd highly recommend next year. I think it's going to be the same time of year, right, Sean? I think it's in Vegas in May.
Yep.
Yeah. So if you can get your requests in early for that, I think it's going to be really beneficial. It was great. Learned a lot. Got to network a lot too.
Yes.
All right. So today we have a user group focused on dates. We're calling it Playdate with Dates, in typical Tableau pun title style. So Leah's going to kick it off with some basic Tableau functions and overview. Liam's going to get into how to do year over year in Tableau, and then I'm going to get into some custom period over period comparisons. So I will go ahead and kick it over to Leah to start off her presentation.
Hi, everyone. I'm Leah O'Rourke. I'm a Data Viz Analyst 2 at Evolytics. I've been in Tableau for about a year, and then I'm also a Tableau Certified Data Analyst. So as we go through the slides, please feel free to ask any questions in the chat. Like Jay mentioned, we're going to start very basic with our date features. And so when we start to work with date fields, there's two ways to use them, either discrete or continuous. Discrete meaning individually separate and distinct. So if, for example, we wanted to look at sales by month, we might make this bar chart by selecting month. And at first glance, it's exactly what we want. However, the data set has 4 years of data, so Tableau is actually going to group every month together. This is where we might find that using a continuous date field to make a line chart is a better option, where continuous meaning forming an unbroken whole without interruption. So if we change our date field from showing the date part of month or the discrete month to the date value of the month or continuous, we can see a point for each month in the year in chronological order. I'd also like to note that continuous will connect points even if there isn't data between the dates. So as a rule of thumb, we'll remember that discrete is going to draw your headers, while continuous will draw axes. And then discrete can be sorted while continuous cannot. Discrete is also going to show a color for each value, while continuous will show a gradient scale. So in this example, we put date on color, and so in our discrete bar chart, we can see each year has a different color, while on our line chart, it's that gradient scale. And then before we move on, we'll have a Tableau tip. So for Mac, we can use the Option key on our keyboard and drag the date field to the shelf. And then on Windows, we can right click and drag our date field to the shelf. So for beginner users, this is helpful to see all of your date field options all at once. And then for more advanced users, we found that this is a time saver to be able to quickly select what you want without having to switch from exact date to continuous to discrete. Before we move on, are there any questions on differences between discrete and continuous dates? All right. So next, we'll continue into date functions. So we're going to cover a few common date functions that you might use, and then we will have more advanced use cases. So starting off, we have date add. The date add field or function is going to return a new date based on the number interval added to the specific date part of that date. So for example, let's say we work at the sample superstore and we're going to need to calculate when to ship out orders. In order to provide great customer service, we try to ship packages out within 5 days from the order date. We want to see what the latest date that we can ship our orders within that 5-day range. So here we can calculate or create a new calculated field and use the date add function. We want to see at the 5 days past the order date. So we're going to use the day granularity and then 5 for that 5 days. And then we'll add our order date field. So here we can see that if we placed an order on 6/1, we need to ship it out by 6/6. And then we have date diff. The date diff function is going to return the difference between two dates expressed in the specific date part. So continuing with our superstore scenario, even though we try to ship out within 5 days of the order date, it doesn't always happen. So we want to look at when our customers are ordering and then when we're shipping and seeing realistically how many days is it taking us to ship our products. So here we can create another calculated field called date diff, and we can use the date diff function where again, we want to see how many days it takes. And then we want to, as our start date is when the customer orders, and then our end date is that ship date. So here we can see if we had a customer order on 6/1, we have shipped it on 6/3, which is a 2-day difference. But then we can also see that sometimes it's past that 5-day range. Another way to look at this is if production has slowed down and it's taking us longer and it's actually taking us weeks, we can switch our day to weeks. And then from here, we can see that we're usually within that 1 week, but sometimes it might be over. So then the next couple of calculations that we'll go over are often used with more complex calculations. Again, like Jay mentioned later this afternoon, both him and Liam will provide use case scenarios on how they use these functions. So for date trunc, it's going to truncate the specified date to the accuracy specified by the date part and return a new date. So here, if we do date trunc and we want to truncate it to the month on order date, we can see that even in May, June, and July, it's all going to truncate it to the first of the month. And then date part. So that is going to return the date as an integer. So date part here where we want the month and then from the order date. So again, with our 5/7 example, if we go by the year, it's going to give us 2022. And then if we break it down by month, it'll be our integer of 5, 6, and 7. And then by day, 7, 13, and 1. All right. So we can hop into Tableau before we continue and review that. So here we have our order dates for June, and then we wanted to do date add. So we can create our new calculation and add our date add function. And then here we want to do day, and then we'll do that 5-day range and order date. And then from here, we can drag it on. So again, on Mac, we can either use Option or we can use right click and drag it. And then we're going to want the exact date. So we can select our content or discrete. And then we can see that from 6/1, we have that 5-day range. The next is going to be our date diff. So we can create another calculated field. And here we can also point out that as you're using the date functions, if you aren't quite sure what it is going to do, on the right-hand side, it will give you the definition and then an example, as well as all of the parts of the calculation that you'll need to fill out. So again, we can do day, and then our start date is going to be the order date, and then our end date will be our ship date. And click OK. And then here we can drag it out. And then we'll need to change it to discrete. So in our date diff, we can see that there's 2, 4, and 5. So it'll also be helpful if we add our ship date as a discrete field. And then we can see again with the 6/1 order date, we see the 6/3 ship date, which is a difference of 2 days. And then for date trunc and date part, both Jay and Liam, again, will go over those in more detail. All right, so we aren't going to go too deep in the remaining date calculations, but we put together a list of additional date functions that can be used within Tableau. If you're interested in these as we go through, please feel free to screenshot and save it in your own notes. So with the starting of the calculations, max and min, they can be very useful when trying to come up with either the most recent or the first, in this case, order date. And then we'll move on. So we grouped these functions because they are very helpful when you're trying to want to extract a single part of your date field. So if you wanted to return year, quarter, month, week, day, or even if you needed a calculation to see today and now, those are available. And then lastly are the remaining date calculations. So please note that the ISO date functions can only be used on an extract. And then before we begin to build or continue on, are there any questions? All right. So next we'll go into date table calculations. So you may have used quick table calculations like percent of total or running total before, but did you know there's also date quick table calculations you can use? They require a bit of setup before being able to be used. So compound growth rate and year-over-year growth quick table calculations are available when the date field is in view, while year-to-date and year-to-date growth quick table calculations become available when the date field is discrete, aggregated to less than a year, and also it needs to be in the view. So we'll start with a simple table where we will add year to the column shelf, category and quarter to the row shelf, and then sales to the text mark. So we can add year, and then we want our category on rows, and then also our quarter in discrete from that order date to our rows. And then from here, we can drag sales to our text. And we have for each category and quarter and year, the breakout, the sum of sales. All right, so then we can look at the year-to-date total. This is going to calculate the running total for the quarters for each subcategory. So in our example, once we add the quick table calculation of year-to-date total, we can see a running total going up, down. So we have in quarter one, 22,656, and then in quarter two, the 28,064. And it's doing the running total going down. So quarter one and quarter two is going to give you the 50,720. So in our workbook, we can duplicate our table. And then what I like to do in this case is add sales to our marks card. And then we can add a quick table calculation of year-to-date total. And then we'll add it to text. We'll make it a little bigger. And then from here, we can bold and change our running sum so we can see and distinguish it from just our sum of sales. And then if you wanted to go across, we could also change compute using table across, and then that will give us our year-to-date totals across. All right, so compound growth rate. This is going to use the geometric mean, where you might be asking yourself, what's a geometric mean? In layman's terms, we're going to multiply the numbers all together and take the nth root of the multiplied numbers, where n is the total number of data values. So realistically, this table calculation has a very specific use case for financial investment analysis. And if you aren't sure what that is, then you probably won't use this calculation on a regular basis. So here you can see we have our sum of sales, and then we can add the quick table calculation for compound growth rate. And then for year-over-year growth, this is going to calculate the percent change in the value from year to year. It's very similar to the percent difference table calculation. So again, in our example, we start with our base sum of sales values, and then we can add both the percent difference and year-over-year growth calculations and show that they are very similar. So in Tableau, we can start by, again, duplicating our quick table base, and then we can drag sum of sales onto the marks card twice. So for our first one, we want to do percent difference, and then we want to use compute using table across, so that's good. And then for our second one, we also want to use the compound or year-over-year growth, and we'll adjust those to be text, and then we'll need to arrange our numbers. And so here we can see that our percent difference and then also our year-over-year growth are like the exact same. And then our last quick table calculation is going to be to year-to-date growth. This is going to work very similar to the year-to-date function. Instead of calculating the running total, it's going to calculate the percent difference between running totals. So in our example, we have our sum of sales, and then what we also did was add our running total going across, and then our year-to-date growth. So here we can see that in 2019 for quarter one for furniture sales, it was 22,656. And then in 2020, it was 27,374. Those two combined are giving us our 50,030. And then if we look at the year-to-date growth, instead of the difference between our sum of sales, is taking the difference between our running totals. So to visualize it in Tableau, we'll copy our base table again, and then we'll add sales. Here we can do our running total for the first sales, and then for our second one, we can do our year-to-date growth. We'll want to double check that they're both across so that they match. And then we can add it to text. And then one thing that'll make it easier is if we vertically align them. So with our example, we see our starting sum of sales of 22,656, and then for 2020, the 27,374, and our running totals, and then we see our year-to-date growth. If we wanted to, we could also use table down if we wanted to look at this per quarter. So that's something to keep in mind. But that is all for our quick table calculations. I will turn it over to Liam to continue on with our journey of play date or dates.
Awesome. Thank you, Leah. Let me go ahead and share my screen and we will get going. All right, so my name is Liam Huffman. I am the manager of data visualization here at Evolytics. I've been using Tableau for four and a half years. Been doing this for a little bit. Tableau certified desktop associate. And today I am going to be talking about equalized year-over-year comparisons. So these are a pretty common ask for the type of work Leah and I do. We're both consultants, and when we join a new project with a team that's maybe newer to business intelligence, year-over-year numbers are pretty important, right? They really let the teams know how they're growing. Maybe you're comparing against a goal or benchmark from last year. And so it's really important to understand how we're comparing this year versus last. So for us, this would be a pretty common ask. We've been brought in to help a team analyze their sales performance year over year. Current dashboard is not great. It's not super easy to compare sales this year to last, right? We've kind of got date all on one axis. It's spread out by year. So in theory, we could technically do some year over year work, right? We could try and highlight a specific date, match it in the year prior. But that seems really time consuming. We've got some general numbers on the side to give us updates, but overall, it's really hard to understand how sales in 2020 compared to sales in 2021 or 22. And so we want to figure out how we can make the data easier to interpret. And the solution is equalized dates. Equalized dates are going to save a ton of real estate on the dashboard. They're also going to make it a lot easier to find insights and a lot faster. So let's talk through how exactly it is that we end up with a view with a trend chart that looks like this. So our first step in creating an equalized axis is we've got to create our base fields. So there are two important fields we need to start with. The first is the max order date. This is the largest order date in the set. To create this, we actually use a fixed LOD statement. If you caught my presentation last year, right at the end of the year, I went over this where these squiggly brackets, right, if there's nothing contained in between the LOD brackets, it automatically assumes that it's a fixed statement, and it's going to fix that value to every single row in the data set. We're doing a max on the order date. That's going to find the largest order date in the entire set and then fix it to every row in the data set. This is super important. You're going to see why in just a bit, but that max order date field is critical to what we're building. And then the next most important field is our CYPY assignment. There are a couple different ways that you can do this. Jay's going to explain a different method for creating these period assignments in his presentation, but for ours, we're going to start with probably the simplest version. This CYPY assignment takes the year of the order date and compares it to the year of the max order date. So remember, our max order date is the largest date in the entire data set, and so we're finding the year for the most current date. If the years of the order dates equal each other, then 0, right? We've got our current year. If the year right now, or the year in the data matches the maximum year, we assume that that's the current year period. And then we just start going back. If the year of the order date equals the year of the max order date minus 1, then 1, minus 2, then 2, minus 3, then 3. It's really important that whenever we do the changing, so the subtraction in this case, that we do it to the max order date. The reason this is so important is that if we try and subtract 1 from the original order date, well, that's going to be a different value for every single row, right? These order dates are unique by row. So we want to make sure that we are finding the year minus 1 of the maximum order date. That date's never going to, that date is going to be consistent across every row, so the evaluations can be consistent. So if we were to go into our own workbook, whoops. There we go. So if we were to go into a new workbook and build this out, right, we need a couple custom fields. The first is our max order date. It's a little bit bigger. So in our max order date, right, we'll just open with our LOD bracket, max order date. Super simple. We hit OK. And then we can create our CYPY calculation using that max order date. Make it a little bit bigger. So if we do the year of order date equals year of the max order date, then 1, or then CY. No, then 1. Sorry. Else if the year of order date, I'm just going to cheat copy this line, minus 1. Actually, that should be 0. We need it to be 0. It's based on like standard like database indexing. So we want 0 to be our most recent value. Minus 1 is 1. We can copy this entire line. Subtract 2, then 2. Equals -1, then, and then for sake of simplicity, I'm just going to end it here. We know that the third line is going to look pretty similar to all of these. We can hit OK. And so now if we were to drop it into view, let's actually make it a dimension. We don't need this to be super dynamic right now, but if we add it to the view and then we are to drop our order date, I'm actually not going to do the option drag for this one because I want the years to come in. So we can see that we are assigning correctly, right? 0 is 2022, 1 is 2021, 2 is 2020. So we're assigning the values of the years correctly, which is great. The reason, so when we look at the max order date, right, regardless of the order date, we can see that it is consistent thanks to our LOD. That 626 is applying to everything. Then if we take a look at the individual dates, as the table moves down, our PY and CY assignment is climbing up for 1 every year we go down. So we're looking at 1, 2 across all 3 years. We've got 0, 1, and 2 based on the number of years we're going back. After we create those base fields, we've got to create a comparison parameter. This comparison parameter is not necessarily intuitive if you've ever come across it before. We call it the daily comparison against. And within it, we supply 2 different values, 364 and 365. The reason for this is that we want to allow our end users to choose how they're comparing their dates. One method, we can compare against weekdays, so looking at a Monday of this year versus the Monday of last year, or we can compare against the weekday, the 16th versus the 16th. The reason that we allow for a toggle between the two is that that plus 364 can be really important if your metrics are cyclical. Imagine, that you're running sales and on the weekend, your sales are higher, right? We don't necessarily want to compare a Sunday to a Monday accidentally in our view, which will happen in the 365. We want to make sure that we're comparing that Sunday to the Sunday last year. So, the importance of this, right, is that we want to make sure that the end users can swap between the two, that the dates are lining up by 1 less as the dates move forward every year. The day of the week shifts back 1 for the date. This doesn't technically account for leap year. We don't normally worry too much about it. Leap years are pretty rare and don't have a huge impact to the data. So we don't normally concern ourselves about the leap year too much. After we create that parameter, we want to create the equalizer. So this is actually what gets all of our dates to line up. So this is where we're going to use that date add that Leah talked about. We're going to add a certain number of days equal to that PY/CY assignment times our daily comparison against to the order date. So that PY/CY assignment is 0, 1, or 2. The daily comparison against is that 364 or 365. So if we're in the current year, we'd be multiplying 0 times 364, adding that to the order date, which means we're adding 0 days to the current year, which is what we want. But if we were to go back a year, then we have 1 times 364. Now we are adding 364 dates to the order date. And so if we look at it in a table view, right, when we create our equalizer, the way that we've built it right now is based on that 364. That's the default value. So when we look at the data, we can see that right now we are comparing the 26th, the 27th, and the 28th, 27th of 2021, 28th of 2020. They are all showing a 626 date equalizer. But in reality, right, we're comparing these 3 different days, the 26th, 27th, and 28th. but they all happen to be a Sunday. And so we allow the data to stack on top of itself so that we are comparing Sunday to Sunday to Sunday. If, however, we switch it to 365, now we're comparing 3 different values, right? Or now we're comparing 3 of the same date, but we're comparing different actual days. So the 26th, 26th, and 26th, we've now got a Sunday versus Saturday versus Friday. So 3 completely different days of the week. If, again, we don't, if we don't care about that and we really do just want the number of days, that's great. But we do, want to make sure that we account for people switching to look at that cyclical view. It's also important to note, and we'll get to it in a little bit, but this only impacts daily data. We do not translate this over into monthly. We don't want to be pulling in days from a random month into the one before or after. And we'll talk about how to fix that in just a sec. So right now with our equalized dates, if we were to hop into a view and build this out really quickly. So we need to create our parameter. We're just going to do an integer list. We're going to choose 364, 365. We'll call this the daily comparison against. Hit OK. And then in our calculated field, we'll do as a date, just so that we don't pull in any date times. We're going to do that date add a number of days equal to the CYPY assignment times our daily comparison against, and add that to order date. And this is equalized date. So now if we drop this equalized date on a row, add it to columns, we want it continuous. You'll see already that we're only showing data from the most recent year, right? We're not including any 2020 or 2021 data. It's 2022 on. If we were to drop sales on here, the sales look pretty high. That's because right now we've got 3 dates being added to most of these values, all the prior year values. So we need to make sure we split out the years. So we can just drop our order date on color, and that will default to year. And then we're going to get a blue, red, and gray for each of our years. Now we've got them all stacked up on top of one another, and this is already more useful. We're able to actually select a date or something, and we can compare against values on the same range. That said, this is still really busy. This is a lot of information, and daily might be a little too granular for what we want. Oh, and here's that toggle, right? So that 364 plus 365, when we compare the dates on plus 365, everything is 626. When we shift it to 364, we're going to be comparing the 26th, 27th, and 28th. All right, so we know daily is a little too granular at this point, so we want to allow for different granularities or date aggregations, as we call them. So we want to make sure that in our date aggregation, we include all the different date ags that our clients might use. In this example, we care about the day, week, and month. So daily, weekly, and monthly values. When we build this, I build it as a string parameter where I'm going to input the values lowercase, that lowercase day, lowercase week, and lowercase month. We'll display them as capital so that it looks nice, but displaying them as a string lowercase is actually a little trick that we are going to get into right now. So in our next calc, we're going to update our equalizer to be truncated. So we've used the date add before. Now we're going to use the date truncation. The date truncation is a great way to leverage that date aggregation of lowercase values. So in this statement, right, we're evaluating on the date aggregation. So when it's day, we're going to use our standard original value of adding a number of days that equal to the PYCY assignment times the daily comparison against to the order date. So 1 times 364 added to order date. But when it's not date, we don't really want to recognize this daily comparison against, because like I said, we don't want to pull in the last day of the month last year into the current month this year. So we're strictly going to add 365 days. That will always be the amount that we add for anything that is not day. So we're going to drop in our date aggregation parameter. This is where that lowercase comes in handy. By adding in the parameter as lowercase, we don't have to build out a case statement that says case when date aggregation or case date aggregation when week, then a separate line for week, when month, a separate line for month. This evaluates immediately for us. Then we'll use our date add, a number of days equal to 365 times the number of years back to our order date. And so in our workbook, if we were to take these steps, we'd create our parameter. We'll do date aggregation. We'll call it a string. We'll do a list, go day, week, month. I'm not going to worry about the display as for now. That's for your end users. We'll keep it at day for now. Hit OK. And then we'll create a new calculated field. This is the equalized date truncated. Cool. And so now we will do a case statement on the date aggregation. There it is. When it's day, then I'm just going to pull in our original equalized date. Else, we're going to do a date trunc on the date aggregation of the date add, a number of days equal to 365 times that CYPY assignment. And then we're going to add that to our order date. And so now we've got a little bit more of an advanced date truncation or equalized date. So once I hit OK, I am going to drop this. Oops. I'm actually going to change it from date and time to just date. We're not worried about the time. I'll option drag this to columns, choose continuous. Then we'll drop off the equalized, the original equalized date, go back to one axis. And then if I show the parameter, the date aggregation, now we can shift between day to week, much easier to read, and then month. We'll see that when I switch between the daily comparison against, nothing is changing on the monthly level. Nothing is changing on the weekly level. That's good. But on the daily, we will see the graph shift just a tiny bit. Everything just moves by one day. So this is working right now exactly as we wanted. But something you might have noticed is that when we look at maybe the week or even the month view, our data for the current year stops in June. And so we've got a bunch of extra data out here to the right that we really don't need right now. It's not helping in our analysis. It's just taking up space and distracting us from the period that actually matters. So to fix that, we can do a filter out future. The filtering out the future makes sure that dates beyond the current max order date don't show up in the view. It limits the data so that we don't have any weird, sometimes databases love to include future dates randomly. This makes sure that those awkward future dates with maybe fake data or wrong data don't populate. It makes sure that our prior year values that are beyond today's date are not getting displayed in the view. So it's really decluttering what we have going on. Luckily, the future date filter is super simple. We're just creating a true false statement, trying to make sure that our date equalizer is less than or equal to the max order date. Technically, we could just use order date less than or equal to max order date. That would work as well. Sorry, we can't use the regular order date because those future dates are technically less than the max order date, but they would show up in the view if we allowed them. The date equalizer, everything is rounded up to current year. And so we're able to evaluate that only in terms of the current year that the date exists less than the max order date. So if we were to create that in our view, the future date filter, then we would just be taking the equalized date truncated less than or equal to the max order date. We'll hit OK. And if I were to just so that we can look at it, if I drop it on columns, then you'll see that false, right? All of our data is from July 1st on, and all of our true data, what we want to include is June 1st back. So if we were to drop this on filter, only true, then we're only seeing data up to the current period. This works even if we go down to date, right? We're now all capping out at the 26th, and in week, same thing. It's capping out at the exact right place. So our future date filter is working as anticipated. We're only seeing the current, up to the current date. So now we've got a pretty robust trend line, right? But there's still one thing missing. This is great if we want to look at the entire year all at once, but normally that's not how our stakeholders use their dashboards. Normally they're looking at a very specific time range. And so what we want to do is allow for those custom ranges. We want our end users to be able to dictate the months or days in their view. So we're going to need a couple more fields to get this done, and then we'll have a beautiful trend line. The first thing that we'll need to create is our minimum start date. So the minimum start date looks really similar to the max order date, right? We've got the max around a date. It's a fixed LOD, so it's going to apply this everywhere. However, we do want to subtract 30 from it. Technically, this 30, right, that is just a date or a number of days we're using for this example. You need to ask your stakeholder or whoever's owning this dashboard what the default days number back should be. Technically, right, we don't need the LOD here for the function to work. We'd still get the max order date minus 30, even if we didn't have the LOD. But by using the LOD, we're able to auto-populate our parameter. So we'll now need to create our parameter of start date. We're going to just set it as a range. And then when the workbook opens, we want to make sure that the date equalizer is the date range is populating. That's going to be, that's going to make sure that only the start of the year to the current point are options. And then in this value when workbook opens, I've set it to be this min start date that we created. And this is why we need an LOD around the field. If we don't have an LOD, then this min start date will not be an option to load the workbook. It's not a consistent value. And so we want to make sure, or Tableau thinks it's not a consistent value. By using the LOD, it makes sure that that Tableau registers that this is the date we should start with every single time. And the important thing is that this will update, right? So that when it's not 5/27 is 30 days back, in 3 days, it'll be 5/30. This will update to be the most correct date, so you don't have to go in and adjust the workbook yourself later. We also need to create our end date parameter. So here, again, we're using the date equalizer as our range, and then we're adding in that max order date like we did to the min order date in order to ensure that we are defaulting to allowing the last date in the range in the view. And then the final field is our custom date filter. So this is going to be what we use to actually filter the view to only include the dates selected. So we're just looking for when the start date is less than or equal to the date equalizer, and when the end date is greater than or equal to the date equalizer. We're looking for the spot in between. So if we were to create these final calcs in our own view, we'll start with creating our min start date. So we are looking for an LOD of the max order date minus 30. There we go. Important to note that we do need to wrap this statement in a max, right? Because LOD calcs disaggregate the calculation. So we need to re-aggregate it within the LOD. So we've got our max of the max order date minus 30. We're going to create our start date parameter. This will be a date, it will be a range. We want it to open with the equalized date. And when the workbook opens, we don't want current value. We want it to be the min start date. We'll hit OK. And then I'm just going to duplicate this start date, edit this to, instead of being min, we're going to do max. And this is going to be the end date. We'll hit OK. And now we'll create our last calculated field. So this will be the custom date range filter. Bigger. And so we are looking for our start date to be less than or equal to our equalized date, and our end date to be greater than or equal to our equalized date. We'll hit OK. And then let's make sure that we show our end parameter, or our end date and start date parameters. So right now, when we filter the view, we should only see between the 27th of May and the 26th of June. So let's drop on our custom date range filter, select true. All right, we've got it in weeks. So let's look at it in day to make sure, do some testing, 27th through the 26th, perfect. So now we can use these to adjust dates back and include more in the view. Right now, we're able to create or to expand our dates as needed. What's really neat is that if we go beyond the future date or the max date, it still cuts out, right? It's not going to allow those dates to populate if your end user strayed too far out because we've got this future date filter on there. So this prevents, any accidental usage where they're creating a view that may not be exactly what they're looking for. And so this is essentially the final product for what we would deliver to a client in order to have a full functioning year-over-year comparison dashboard. This, again, lets us choose between whether we're comparing on weekday versus weekday or weekday versus weekdate. We're able to change our aggregation from daily to weekly to monthly. We're able to choose a custom range in between those values. So maybe the March 1st to May 20th, right? And then we've also got our future date filtered out. So All of this is on my Tableau public profile. If you are interested, you can go download the workbook. It's going to contain the original view as well as the revamped. That includes a little bit more interaction to see what an end dashboard for a client might look like that we use. And then I've also added this comparison view so that you can kind of see what I like and dislike about each views, what the power of each one is. And with that, I will roll it over to Jay to talk about even more complex date comparison ranges.
Great, thanks, Liam. Yeah, so I'm going to piggyback off a lot of what Liam just showed and get it into period over period. So let me get this going. Everybody see my screen? Yeah. All right. Yeah, and just to reintroduce myself, I'm Jay Farias. I actually changed jobs. I do no longer work at Evolytics. I work at Action Analytics now, as of last week. So I have been in Tableau for over 5 years now. And I do help lead the Kansas City Tug. And then after hours, I like activities like rock climbing and yoga and stuff. So, all right, let's get into custom period over period date comparisons. So Liam just showed us year over year, but what if your client wants to see other things? So this presentation is going to be pretty advanced. It's going to focus on syntax and concepts, and it assumes you know the basic date functions that we just went over, how parameters work, how to apply filters, all that kind of stuff. We're just going to mainly focus on the complicated syntax to get these features to work. So our use case is our stakeholder wants to see trend charts comparing sales for week ending, month to date, and custom rolling periods. And custom rolling periods being like last 7 days compared to the previous 7 days, or last 30 days compared to the previous 30 days, just like these rolling dates. All right, so it's helpful to know where you're going before you start building. I'm not going to go into the wireframe process. This is where we wireframe. But for the purpose of this presentation, I'm going to show you our finished dashboard and just highlight some of the features that we're going to be building. So the first thing we're going to need, we just discussed our periods that we're going to want, like week over week, month to date, and rolling end days. So that we're going to need a parameter that has those. Also going to add in a little extra ability for the user to show the last n number of periods where they can control, last 8 weeks, last 8 months, whatever. Enhance the user experience a little bit. And we're going to need a parameter to control the number of rolling days where they want to see 7 or 15 or 30. We're also going to need some date filters for the period types that we need to limit. So we don't want to show incomplete weeks and we don't want to show incomplete months, right? If we're doing month to date through the 27th, we don't want to show the last 3 days of last month. And we're also going to need date grouping for each of the period types, which will also act as a label. We need to group truncate into the periods that we want. So just to recap, the main features we're going to build: a parameter to toggle period types, a parameter and a filter for showing the last n number of periods, a parameter to set the number of days in the rolling period, and then date filters for the period types, and then date grouping for each period. All right, so let's build. I'm going to show everything in the deck, and then we'll review the dashboard in Tableau at the very end. So the first thing we need to build is a parameter, pretty straightforward for the periods. I'm just going to use a string here. Wow is usually the term we use for week over week. MTD is month to date, and then rolling end days. I also like to put a P in front of all my parameters, a lowercase p, just to make it easier to pull them into calculations and differentiate them from maybe calculated fields that have the same exact name. So you can tie your parameters to calculated fields and they're not named the same thing. All right, so next we'll go into building what's required for each of the date types. And within these, we can start to build the other features and put it all together. So week ending date. I've set this data set that I'm going to use the example to be today's date. And so for week ending, if you use the week function in Tableau, if you put it up on the shelf or the date trunk week, it's a date trunk, and it's going to truncate it to the beginning of the week. So if we use that week function by default for today's date, 6/27, we're actually going to 6/26. Tableau's default week is Sunday to Saturday, which Sunday to Saturday is what we want for this use case. That's the week we're going to be using, but we want Saturday's date. We don't want Sunday's date. So we're going to have to do some calculations here to get the desired output, which is going to give us this. So for this week, today's date of 6/27, we're going to want an output of 7/2. And for last week, we're going to want 6/25. We're going to want the Saturday's date of the week. You see the calendar there for reference. So to get that, our week ending date grouping calc is not too complicated. We're going to use a date trunk function there in the inner part. So we're going to truncate our order date to the week, and then we're just going to add 6 days. So it's going to take every date that we have, it's going to give us the Sunday of the week that it's in, and then we're just going to add 6 days to that to get Saturday. So pretty straightforward. We're using the date trunk calculation here, and we're using the date add calculation here. So here we go. This is the output I just showed you. This is what we get from it. But if you'll notice, we get, for today's date, we get 7/2, which hasn't even happened yet. And so we're actually going to need a filter to filter those 2 days out, because when we're doing week over week, we don't want to show an incomplete week. We don't want to show 2 days of this week compared to 7 days of last week. So we'll have to build a filter. So this is the date filter for week over week. It basically evaluates if the max date in the data set is Saturday, then we want to include that whole week. Else, we want to just include prior weeks. So this will happen like a business use case will be, your data refreshes daily, and then on Sunday, you only have data through Saturday. You don't want to exclude that previous week. You want to include it even though you don't have new data for the current week. So this will help you with that. It'll just give us the weeks that we want. And I always write my date filters, kind of like Liam showed too, to return a Boolean, just to select true on the filter shelf. So I always know, just put it on and hit true. All right, so let's get into month to date. All right, so month to date, just like the week function in Tableau give us the beginning of the week, the month function in Tableau gives us the beginning of the month. It's simply a date trunk on the month to give us the first day. So for every month, it's going to be the same. It's going to be like 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, etc. So we actually want, though, our desired output is we want the last day. We want the month to date for each month. So for June, for today, we're going to want 6/27 because that's the day we're at right now. And then for May, we're going to want 5/27. We're going to want all the data up through that 27th day in the month. And you'll notice here as well that we still get a grouping of 5/27 for every day in May. So for 5/31, we're still getting 5/27. We don't want those last 4 days. So we'll need to write another date filter to exclude the days that we don't want to include. All right, so this calculation is a bit complicated. Essentially, we're going to look at, I'm going to go through this with a couple examples, but if the month of the date is the current month, then we're just going to use the max date in the data set. So if we're in June, like it's June right now, so if the date we're evaluating is in June, we're just going to use the max date, which is 6/27. Else, we're going to find the same day of the current max date in each month, so the 27th of each month, and then else we're going to add a month to the date, truncate to the first day of the next month, and then subtract 1 day to get the last day in the month of the original date, and then compare those. So let me go through this with some examples, make it a little bit easier to understand. And this again leverages the max date field that Liam has explained in the previous presentation. I call it order date max, just so the naming convention stays the same in my left-hand pane. But let's look at an example with an order date of 5/15. So I've got that isolated, the part of the equation we're going to look at. I've put the dates in that we're evaluating. So if the max date is today, 6/27, and the order date is 5/15, basically it's just going to evaluate. To the left side is going to give us the date, the max date we're going to add the day number of the max date to the beginning of the month of the order date we're evaluating. So we're basically going to add 27 days to May 1st and then subtract 1 because we're starting at 1 instead of 0. And is that less than or equal to the last day in that month? So is 5/27/2022 less than or equal to 5/31/2022? And it is. So that's going to evaluate true. So we're going to take the left side of that equation, and that's the date that we want. So for max date of 6/27 and evaluating an order date of 5/15, we're going to take 5/27 for the grouping for that day. And that'll go for any day in May up to the 27th. So let's look at a use case where our max date is larger than, like the day is larger than the order date. So if our order date is 2/15 and the max date in the data set is 5/31, then same thing, we're going to add basically 31 days to the beginning of February, but that 31 days is actually going to put us into March. So the left side of the equation ends up at 3/3/2022, but the biggest day in January or February is 2/28. So instead of taking the left side of this first equation, we're going to take the right side. So we're not going to use 3/3. We're not going to take the adding the number of days. We're going to take the right side, which is the max number of days in that month. So we're going to get 2/28 here. Again, this equation uses a lot of different function. It uses date trunc, it uses date add, it uses date part, all in different combinations. And we also use like LOD there with the order date max. So kind of bringing all of our date functions together to evaluate, to find the grouping that we want for the month to date. Okay, so here's our output. So for June, we get 6/27. For May, we're getting 5/27. But notice we want to trim those 4 days out that haven't happened yet as far as the day numbers go. So this filter is a little bit simpler than the week one. Basically, we're just going to look at the day of the order date that we're looking at, that we're evaluating. And is it less than the day of the order date max? So the day function here is going to return an integer that's simply 1 through 31, right? Some months have 28, some months have 30, 31, but those are the possible values. And is it less than or equal to? Then if it is, we're going to include it. If not, we're going to exclude it. So let's see if this is working. We put it on our filter shelf. We see there on the right for May, yes, it works. We only get through the 27th day of May because our order date is, our max date is June 27th. So another thing I wanted to do was manually test if that February use case worked. And how you can do this is you can actually go into your max order date max field, and you can manually input a date. This is really handy for testing purposes, whether you're using the today function or just hard coding a date. You can use the hash signs and then put in a date with year, month, day, and it'll put that date in there. And so we can simulate that the max date is actually June 30th, and then we can go look and see if our grouping calculation for order date, month to date, is evaluating to 228, which is what we want, and it is, so it works. All right, so let's get into rolling end days now. So here, our desired output, we're actually going to group in end periods. So I'm going to use the example of 7 for here. So we're going to group group the days and periods of 7. So 6/27 down to 6/20/21 is going to evaluate as 6/27. 6/14 to 6/20 is going to evaluate as 6/20. So the last day in that period is what we want. So we're kind of just truncating at the end of the period. So this one's a little more complicated. So let's look at each of the primary fields we need to make for this. We need a parameter to set the period length. We need to create a calculated field using the modulo function to determine the days to add to a date. And we need to create a calculated field to assign the rolling period date grouping. So that final field is kind of what we did with the month to date and the week over week. We just have a few extra steps to get there with this one. So that parameter is pretty simple. Call it p rolling n. It's going to be an integer. You could set the range like 0 to 30 if you wanted to, probably 90. I just put all for this. We're going to use 7 as our default value. All right, so modulo calculated field. So this is going to return the days to add to each date. So if you're not familiar with the modulo function, it's basically the remainder if you take two numbers and divide them. So we're going to take the date diff in days between the max order date and the day we're evaluating. And then we're going to divide that by the parameter we just said, so p rolling n. And this is going to return an integer. So here's our numerator. Here's our modulo function. It's just percent sign. And then here's our denominator. So that's the format of the equation that we're going to use. So let's look at an example. So let's look at an example of if we're evaluating June 20th and the max date is June 27th, there's 7 days difference there. So 7 divided by 7, we're going to get a remainder of 0. There is no remainder of that. It goes in there exactly one time, right? So that's going to evaluate to 0. Another example is if we use the evaluate the date of 6/18 and our max date is 6/27 divided by 7. 9 goes into 7 once with a remainder of 2. So this field's going to evaluate to 2. We're going to get 2 days here. So this is what it looks like. And I've made another calculated field in this table so we can see what the date difference is going to be. So that's just going to keep going up by 1 for each day, right? And then we have the p rolling n and then the modulo function. So the modulo is going to return for a p rolling n of 7, it's going to return values of 0 to 6. So it's going to reset every 7 days back to 0. So what we're going to do with this is we're simply just going to add what we get from the modulo function into the order date to get us to that end date in the period that we're looking at. So just the date add day, modulo, and our order date. And here we go. Now we can see the math here. So for 6/27, we're going to add 0 days. For 6/26, we're going to add 1 day, 25, 2, and so on. Till we get down to 6/20, we're going to add 0 days again. It's just going to repeat like that. All right, so the last feature we're going to add is last end periods. This is like little extra credit. So we want to supply the user with a way to control how many periods are displayed in the dashboard and how it be dynamic. We just want to create the best user experience possible, and usually that's by allowing them to manipulate the more features, more interactivity. So the primary fields we need here, we need to create a parameter, control the number of periods. We need to create calculated fields assigning period numbers for each of the period types. So week ending, month to date, rolling end days, and then create a calculated field to filter for the period numbers. So this parameter is going to be simple. You probably want to make this a range as well, but we're just going to make it an integer, p last end periods, and set it at 8 as a default. All right, so creating calculated fields assigning period numbers. This one we're going to use the date diff function. So we're going to look at where for week ending, we're going to use the week ending field that we've already created. We're going to look at the max week ending, evaluate the week ending, and just take the difference in weeks from that. So it's going to give us like 0, 1, 2, 3, and so on. How many weeks is it away from the max week? And then for month to date, we're going to use the same thing. We're going to take the max order month to date. I didn't create explicit fields for these. This is the only place I use them. So I just kind of made those with that level of detail that fixed in these calculations. So we're going to take the number of months away the order date is from the max order date month to date. The rolling end rolling end days period is a little bit more complicated. This one's going to find the difference in days between the ending period date and the max ending period date. Then we're going to divide by the period length, so that p rolling n, and then we're going to round up. So that ceiling function is going to round up. So we always want to round up here, because if you just let it go, it might round down if it's below half, and it'll round up above half. But we always want that next period here. So here's what it returns. If we're looking at June 6th to June 27th, we can see the period date weeks gives us a 0 for the current period that we're in. And we see 1 for the previous week, 2, month to date, we get zeros for all of June. And then the order date period, rolling days, we get 0 for the last 7, 1 for the next 7, 2 for the next 7, etc. All right, so now we need to create a filter, create a parameterized period number filter here based off the period that we're looking at, either week over week, month to date, rolling end days. So we just want the number of periods that are less than or equal to the period that we look. So 8, we want everything to be less than or equal to 8 for a week. So on the week, we use the equals because the date filter is going to filter out that first one earlier. And so remember those date filters we created? So we're going to do the same thing with these 2 filters. We're going to parameterize those based upon the period that we're looking at. If we're looking at week over week, we want to use the week over week filter. If we're looking at month to date, we want to use the month to date filter. If we're looking at R&D, it's going to be true. We're going to look at everything. We're not going to filter out any days for rolling end days. All right, so let's bring it all together. I'm going to cut over to the dashboard. Oops. Where did I put it? So I just started a new job. My Tableau is not working yet. So I'm in web edit on Tableau Public. But this dashboard is pretty simple. It just has 3 main charts. It has this trend chart, or it has the KPI, it has this trend chart, and then it has this period over period highlight table. I've done a very simple tile design, vertical container. The title, I've got a horizontal container right here for these parameters, and I use some blanks for spacing. So let's look at the charts. We went through all the parameters. You can edit the titles, say whatever you want. So for here, the KPI chart, this thing is, I've got the KPI here, I've got a percent change, and I've got like a label here. So this label is actually dynamic. I'm going to go into it first. So for week over week, it says sales last week. For month to date, it says sales month to date. And for rolling end days, it says sales last 7 days. So to create this, I just made this, I wonder if the expand works. Nope. Made this, so again, it's based off the parameter. So when week over week, say last week, when month to date, say month to date, rolling end days, say last, and then I put the parameter in there, last end days. So that gives a nice user experience, letting them know exactly what they're looking at. Also have this through whatever date we're looking at. So for week over week, it's actually going to be through 6/25, right? We're cutting off the date there. And I'm leveraging a caption here so that the label is under the value. I think from a design perspective, the number is more important than the label, right? Like once your stakeholders get used to this dashboard, they're going to know what the metric is. They don't need that front and center. The number is what's going to change. The number is what's important. So try to put the number above the metric or above the label. And you can do that using the caption on the same sheet. It's really nice. And then I have this percent change, which is done via a table calculation. So doing an across table calculation. And to get that to work, you need multiple periods in your view, right? And so I actually have the order date up here. We actually have a discrete header using order date. And then for table calculations to work, I went over this in like February's user group, I think. You can actually use a table calculation filter here to just show like the last. So I'm filtering it to 0. And if I take that off, then we'll see actually every value that is here. But the last essentially hides it, but still makes it available for a table calculation to work. So a little trick there. And then to get this formatting, I think I can bring it up here, I hope. Can't. So this is custom formatting, and it just uses the Unicode character for, sorry, I can't bring this up in web edit, but it uses a Unicode character for the up triangle and the down triangle. and you just go into custom and put the percentage and put one for positive, one for negative. So it's not a shape, it's actually just formatting. It's really handy. You can't color it, but it's really easy to implement. So you can download the workbook and get into it on your desktop and look at it. So the trend chart is pretty straightforward. Oh, I need to hide this. Can I hide it from here? Yeah. Trend chart is straightforward. It's just a dual axis with a line chart and an area chart. I usually put the area at 15% opacity. I like that combination. And then this highlight table, same table calc formatting with the up-down arrows. Same table calc for calculating the percent change between periods. And I have a different last filter here actually. So because if I use the last filter I was showing earlier, I wouldn't get this first value. And so I created another one here just to show the last n periods is greater than last, and then just put it to true. So that lets me, there's actually one more value over here if I take this off, or all the values are here. They're all here. So here's the dashboard and it works. So let's go through and just play around with it. So week over week, you know, we can show the last 8, or we can show the last 12. Not too crowded. Everything still looks good. Month to date. So we can see, yeah, sales month to date through 6/27, and we get 5/27 here. We get 4/27 here, 3/27 here. Nice and clean. We can see our, yes, this is right. This went up, and then it went down here. And then for rolling end days, we can change this. This is last 7 days. So we get 6/27, 6/20, 6/13, or we can do like, you know, 15 days, or, you know, 30 days is pretty popular. So last 30 days for 8 periods. Maybe you want to see like the whole year, so that'd be 12, right? So here's the last year essentially in 30-day periods. So really powerful. You can do a lot with this. A lot of functionality. Where'd my presentation go? All right. For review questions, so you can get this dashboard on Tableau Public at my profile. So it's, you can search custom pop date comparisons, it'll be there. Don't forget today's recording is also on YouTube. So we went over a lot of syntax and a lot of tutorials. I know it's really dense, but it's really packed with information. So if you go to, if you search for virtual Tableau user groups on YouTube, then you can actually see every user group recording, but ours will be on there. You can find the Kansas City one from today. You can go through, maybe slow it down if you want to implement some of this stuff, grab the syntax out. It'd probably be more beneficial there. And also, we've got a lot of resources at my new company's blog, actionanalytics.com. There were some questions. Can you show the last calculated fields? I just did, just go download it and you can grab everything out of there, because there's even more in there that I didn't really show. I went over the main stuff. So it's on Tableau Public right now. Just go grab it and dive through. And I've also got some other sheets in there for reference, just so you can see how the calculations are playing out as well. Yeah, the month to date, I think that's it's a common ask, and I think it's really powerful. And your stakeholders will love you if you can get it for them. Any other questions? Cool. Awesome. Well, thank you, everybody. I appreciate. I know today was pretty dense, but hopefully somebody learned something. Everyone learned at least one thing. Sean, do you have any comments? When's our next user? Are we do something in person?
Yeah, so that's what I was going to say. We are absolutely willing and ready to get back out there. We are looking for a venue. So if anybody has any ideas on a venue that could hold a good amount of people and is hopefully free, it'd be great. So reach out to any of us, Jay, myself, Aaron, or Lucas, anybody who you know of, and let us know if you've got an idea of a place that could hold us, or if your company wants to host, that'd be great, and we'll make it happen. So that's what we're gonna do.
Yeah, and if you're not, there's a Tableau user group Slack. If you're not on that, I would advise get on it. We'll post the link to the recording today, and that's also you can reach, me, Sean, Liam, or Leah. If you have any questions about anything at Tableau, just hit us up, and we can for sure point you in the right direction pretty quickly.
Yep, I'm posting the Slack invite now. So if you want to come join us on Slack, KC Tug, join us on Slack and hang out with us, talk to us, all that kind of fun stuff.
All right.
All
good.
Yeah, that was great stuff, guys. Appreciate taking the time to walk through those things. It was pretty great. So yeah, awesome stuff.
All right. See you, everybody.
All right. See ya.